Part B. We're going to practice for exam 3 again. Let's try question 1. Let's convert 3, 4, 1 to base 8 into base 10. Now the exponent for this one is a 0. This is a 1. This is an exponent of 2. And this is an exponent of 3. Since we're converting it to base 10, this is equivalent to 3 times 6. This is equivalent to 3 times 8 cubed. The 3 is the number in the front. The 8 is from the base. And the 3 is the exponent. The next one's going to be 4 times 8 raised to the second plus 1 times 8 to the first plus 2 times 8 to the 0. So let's simplify this on a calculator. This is equivalent to 1,536 plus 4 times 8 squared is 256. 1 times 8 to the first, that's 8. And 2 times 8 to the 0 is 2. Let's add all this up. This gives me a solution of 1,802 in base 10. So please double check my work. Make sure you got the same thing. Let's look at question 2 now. I want to convert this from Babylonian to Mayan. Remember, their base system is base 60. This is equivalent to 1. This is equivalent to 11. And this is equivalent to 2. But remember, we're talking base 60 here. So this is 1 times 60 to the second power plus 11 times 60 to the first plus 2 times 60 to the 0. Again, this one is an exponent of 0. This one's an exponent of 1. This one's an exponent of 2. So we can write our solution now. 60 squared times 1, that's 3,600. 11 times 60, that's 660. And 2 times 60 to the 0, that's 2. Let's add all of this up. And I have 4,262. So this is equivalent to 4,262 converted from Babylonian. Example 3, let's convert 322,728 into Mayan. Now remember, the Mayan system is special. It's a modified base 20. 20 to the 0 is equal to 1. 20 to the 1 equals 20. And then this one's special. This is 20 times 18. 20 times 18 is equivalent to 360. And then we'll do 20 squared times 18. And that gives me 7,200. And we'll do one more, 20 cubed times 18. That's equivalent to 144,000. So to convert this to Mayan, we'll start with the largest base that goes into 322,728. That's going to be this one. So how many 20 cubes times 18s will actually fit into this number? So we'll have to divide 144,000 into our number. Now, this goes in there approximately 2 times. 2 times 144,000 gives me 288,000. I subtract, I get 34,728. Now we're going to look at the next power of 20 times 18. That's 20 squared times 18. So we'll take 7,200 dividing into 34,728. 7,200 goes into 34,728 about 4 times. 7,200 times 4 gives me 28,800. Let's subtract. And that is 5,928. We'll take the next power of 20, which is 20 times 18. We'll use 360 now, dividing into 5,928. And the closest I can get to this is 16 times. $360 times 16 is 5,760. Let's subtract. I get 168. Then we'll look at the next power, and that's going to be 20. We'll take 20 and divide to 168. The closest I can get is 8. 8 times 20 is 160. Let's subtract. I get a remainder of 8. Now let's put all of this together. We have 2 20 cubes times 18 in this number. 4 20 squared times 18s. 16 20 times 18. 8 20 to the first, and finally 8 20 to the zeros. So let's write our solution in Mayan. Remember, they write it from bottom to top, so we're going to start with the 8. We have an 8 here. Then we'll write another 8. Then we'll write 16. Then we'll write 4. And finally, we'll write 2. This is our solution in Mayan. The Mayan system is probably one of the most difficult systems to use because they have this modified base 20. So just be careful. Make sure you can do this problem with the Mayan system. In 4, let's convert 2016 to Egyptian. I know 2016 is equivalent to 1,000 plus 1,000 plus 10 plus 6. Let's write 1,000 in Egyptian. That's the lotus. And we'll need 2 of these. And the 10 is a heel bone, so we'll need 1 of those. And a 6 is our staff. So we'll need 6 staffs. 1, 2, 3, 4, 5, 6. This is our solution in Egyptian 2016. Question 5, let's use the scratch method to perform the operation. So in this problem, we're looking at base 5. I have 0, 1, 2, 3, 4 is the only acceptable symbols here. So let's add. 3 plus 4, that's 7. That's not acceptable. 7 in base 5 is 1 remainder 2. So we'll put a little 2 down here. 2 plus 4 is 6. Put a scratch. 6 divided by 5 is 1 remainder 1. We'll put a 1. 1 plus 3 is 4. 4 plus 1 is 5. We'll put a scratch. We know 5 divided by 5 is 1 remainder 0. So we'll put a 0 here, and that means we'll bring it down here. We have 3 scratches, so let's carry a 3 over. Three plus 3 is 6. We'll put another scratch. I know 6 has a remainder of 1. 1 plus 2 is 3. 3 plus 4 is 7. We'll put another scratch. And I know 7 is 1 remainder 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 divided by 5 is 1 remainder 3. So I know this is going to give me a remainder of 3. So we'll put a scratch. And then a 3. We'll bring that down. And let's see how many scratches we have. We have 1, 2, 3. So we'll carry 3 over. Our solution is 3, 3, 0, base 5. In question 6, I want to multiply 469 times 75 using the lattice method. Now, of course, I could check on a calculator, and this should be 35,175. But remember, we have to use the lattice method or we don't get any points for this question. So let's use the lattice method. We'll make a box. 469 goes on top and 75 goes on the right. Don't forget your diagonals. And now we can multiply. 4 times 7 is 28. 6 times 7 is 42. 9 times 7 is 63. 4 times 5 is 20. 6 times 5, that's 30. 9 times 5, that's 45. We'll have to add our diagonals. This is a 5. 3 plus 4 plus 0, that's 7. 6 plus 2 plus 3 gives me 11. We'll put a 1 here and we'll carry that 1 over. 1 plus 4 plus 8 plus 2 is 15. We'll put a 5 here and we'll carry that 1 over. 1 plus 2, that's 3. So here's our solution using the lattice method. And that is 35,175. And that is the correct answer. So I know I did this question right. Question 8, we're adding 4132 base 5 plus 343 base 5. Let's look at our acceptable symbols, 0, 1, 2, 3, and 4. We'll start by adding from right to left. 2 plus 3, that's 5. 5 is equivalent to 1, remainder 0. Put a 0 here, and then we'll carry the 1. 1 plus 3 plus 4, that's 8. 8 divided by 5 is 1 remainder 3. Put a 3 here, carry that 1 over. 1 plus 3 is 5. I know 5 is 1 remainder 0. Put a 0, carry that 1 over. 1 plus 4 is again 5, but 5 is equivalent to 0, and we'll have to carry that 1. So our solution for number 7 is 1, 0, 0, 3, 0, and don't forget your base. This is base 5. For question 8, don't forget we need to borrow. So we'll subtract 1 from 0. Can't borrow from the 0, so we'll borrow from the 1. That becomes a 0. We'll have to add a 2 back to here. Then we can borrow from the 2. That becomes a 1. And this is going to be added with a 2. 2 minus 1 is 1. 1 minus 1 gives me 0. 0 minus 0 is 0. I can't subtract a 1 from 0, so we'll borrow from this 1. That makes this a 0. But we'll have to add a 2 back to this 0. 2 minus 1 gives me 1. And this is just a 0, so we'll leave that alone. Our answer is 1, 0, 1, base 2. In question 9, we're multiplying to 2 base 4 times 1, 3 base 4. Now the only symbols in base 4 is 0, 1, 2, 3. So if you get anything larger than this, you got to convert it to base 4. Now I could use the lattice method or I could use the standard algorithm. For this question, I think the lattice algorithm would be pretty doable. And let's try that with the lattice algorithm. Now you could do the standard algorithm, you'll get the same answer. Let's multiply now to 2 base 4 times 1 3 base 4. Two times 1 is 2. I'll put a 0 and a 2. 2 times 1 again is 0, 2. 2 times 1 is 0, 2. Now 2 times 3 is 6, but 6 does not exist in base 4. 6 divided by 4 is 1 remainder 2. So we'll put a 1 and a 2. 2 times 3 is again 6, or 1, 2 in base 4. 2 times 3 is again 1, 2 in base 4. Now let's add our diagonals. This is a 2. 2 plus 1 plus 2, that's 5. 5 does not exist in base 4. 5 divided by 4 is 1, remainder 1. I'll put a 1 and carry the 1 over. 1 plus 0 plus 2 plus 1 plus 2 gives me 6. 6, I know that's going to be a 2. I know that's going to be 1, remainder 2. So we'll put a 2 here. And then we'll carry that 1 over. 1 plus 2 plus 1, that is going to give me a 4. 4 does not exist in base 4. This is equivalent to 1 remainder 0. So we'll put a 0 and we'll carry that 1 over. This leaves this as a 1. So let's make sure we write down our solution properly. Our answer is 1, 0, 2, 1, 2, base 4. Practice the standard algorithm and make sure you get the same answer, 1, 0, 2, 1, 2, base 4. In question 10, we're going to do long division with base 6. Let's look at all the possible symbols in base 6. So we'll have to multiply 2 base 6 times all of the possibilities in base 6. So let's give it a try. 2 base 6 times 0 base 6, that's 0 base 6. 2 base 6 times 1 base 6, that's 2 base 6. 2 base 6 times 2 base 6, that's 4 base 6. 2 base 6 times 3 base 6, that's 6, but that does not exist in base 6. So if you divide that by 6, you get 1. Remainder 0, base 6. 2 base 6 times 4 base 6 is 8, but 8 does not exist. If you divide that by 6, I get 1, remainder 2, base 6. 2 base 6 times 5 base 6 is 10 base 6. Divide that by 6, I get 1, remainder 4, base 6. So this is all of the multiplications with 2 in base 6. Now we could do long division. 2 base 6 dividing into 2, 3, 4, 5 in base 6. 2 base 6 times what gives me close to 2 base 6? Well, that's going to be a 1. Multiply 2 times 1. In base 6, I get a 2. Subtract, I get a 0. Bring down this 3. And now we repeat the process. 2 base 6 times what gives me close to 3 base 6? Well, I look at my chart. The closest I can get is with a 1. So we'll put a 1 here. 1 times 2 base 6 is 2 base 6. Let's subtract, I get a 1. What do we do next? We bring down that 4. And now what times 2 base 6 will give us close to 1 4 base 6? The closest I can get is a 5. So let's put a 5 up here. 2 times 5 in base 6 gives me 1 4 base 6. Let's subtract. I get a 0. We'll bring down the 5. And now we can repeat the process. 2 times what gives me close to 5? That's 2. 2 times 2 is 4 in base 6. Let's subtract. I get a 1. Now that's our remainder, this one down here. So let's write our answer. Our answer is 1, 1, 5, 2, base 6 with a remainder of 1 base 6.